Hi, welcome to the tutorial on cost function curve. By the end of this topic, you will be able to explain what is cost or lost function curve and differentiate between convex and non-convex curves. Now, let's get back to our problem and try to understand how we can find the parameters m and c which represent the best fit line, that is, give us the linear regression model. We will first start by taking the slope m as 0 and c as 0. So let's see how well this line fits. And then we are declaring an empty list in which we will store the computed values of the y. Next, we will run a loop in which for every point in sample data, we are calculating the corresponding prediction and storing it in the list line. Next step would be to plot the line we have made using the values of m and c along the original data points. Note that we are also calculating the error, that is MSE, with respect to the line we are going to plot. So let's run this cell. We can clearly see that the line we made with the given slope and the intercept models the data very poorly, and the mean square error corresponding to the line is very large number. Let's try to increase the slope of the line and observe the results again. For that, we simply change the slope value of m from 0 to 50 in the previous code. We will keep the value of c as 0 for now. So let's run this cell and observe the resultant graph. We can clearly see that the line is able to fit the data better than the previous line, but still not good enough, and the corresponding MSE is also lower than the previous one, but still very large. Determining the best slope for the line in such a hit and trial way can be a tedious and iterative task. So let's automate this and save our time. For this, we define a function by the name of slope underscore error, and this function takes three values. First one is the value of the slope, and the second one is the intercept, and the third one is sample data. Then we define an empty list called sail in which we will store the points predicted by the line with slope m. Now for every point in the data dot flat area, we calculate the predicted point and store it in the list sail. Once all the points have been predicted, we will use the mean square error function from the scikit-learn and calculate the corresponding MSE and return it. Next, we define the range of values for the slope, that is, different values of slope for which we would want to compute MSE. We name this list as slope. And now, as you can see, this list contains values between 0 and 500 in step 0.1. So, I by 10 Here is the step size, and since I goes from 0 to 5000 in steps 1, I by 10 goes from 0 to 500 in steps 0.1. So this list would contain values as 0.0, 0.1, 0.2 and so on till 499.9. Next, we define an empty list called cost. This stores the values returned by the function slope error. Now we simply run a loop which passes every element in the list slope and stores the error returned in the list cost. Note that we are considering that the value of intercept C is constant and equal to 0. Now let's run this cell to calculate the cost corresponding to all the values of slope in our list. Please note that the cost of a model is nothing but the error MSE of the model. In the next cell, we just organize the calculated list of cost and store it along with corresponding value of slope in the data frame known as cost table. And using the .tail function, we can clearly see the results. Now the best way to understand errors corresponding to different lines with different slope is to visualize it using matplotlib. So let's do that. This plot we have got is called the cost function curve or the lost function curve, which is nothing but the error corresponding to different models, that is error corresponding to lines with different slopes. Now this is an interesting curve and you might ask why. If you would notice, the cost incurred when the slope was 0 was very high as represented by the green dot, which makes sense because our line or our model did not really fit the data well. But as we increase the slope of the line, the cost reduces. We can see that the cost with respect to the line when we assign the slope the value of 50 is much lower and is represented by the lower dot on the cost function curve as compared with when slope was 0.0, which means the line with slope 50 fits the data better than the line with slope 0, as we can see here. Now if we move further on the curve, we can see that the cost keeps on decreasing to a minimum value until a certain value of slope as shown by the red dot. But once we start increasing the slope further than that point, the cost starts to increase again. The cost function curve, which we just saw, falls under the category of convex curves. Now let's discuss convex curves and non-convex curves. Convex curves look like a bowl, which means that the value of the function to which the curve belongs will have a minimum value at a certain point, and the value of the function will increase on either side of this point forever. In the convex curve shown on the screen, we can see that there is only one point of minimum value, and this point is called the global minimum. On the other hand, a non-convex curve is the one that does not have a single minimum. Now in the image shown on the screen, we can clearly see that the curve has a small region which looks like a minimum but is not actually the minimum value. Apart from this region, there is one more small region. These small regions are known as local minima. So that's all for now. In the next video, we will continue our discussion on how to use the cost function curve to find the parameters of M and C of our best fit linear regression model.